If a Tyrannosaurus Rex had, like, somehow managed to build a telescope and, point it up at the night sky, it would have seen a solar system that looks completely unrecognizable to us today.
Oh, absolutely. It's a crazy thought.
Right. Because 100 million years ago, Saturn didn't have rings.
No.
Yeah, the most famous, like, iconic image of our cosmic neighborhood just simply did not exist.
Yeah. So, welcome to today's deep dive, where we're looking at a really fascinating astronomical essay that uncovers basically a scandal hiding in plain sight.
It really is a remarkable story. I mean, we have this tendency to view the solar system as a static painting, right? Like something that was just set in stone billions of years ago.
Well, for sure.
And Saturn is practically a brand logo at this point. You see it on children's lunchboxes, in cartoons, on the covers of science textbooks. We're just so used to seeing that perfect sphere with a hula hoop around it that we don't even really question what we're looking at.
We really don't. And, the mission for our deep dive today is to completely strip away that familiarity.
Yes. We're going to take a warm, unhurried walk through the facts. And trust me on this, you do not need an astrophysics degree to follow along today.
Definitely not.
By the time we wrap up this deep dive, you are going to realize that those cartoonish rings are actually one of the most bizarre, violent, and dynamic objects ever discovered.
Yeah, and to appreciate just how wild the physics of the rings really are, it helps to look at how humans first struggled to even comprehend them. Like, we have to rewind to 1610.
Okay, 1610.
Right. Galilei had just pointed his newly invented telescope at the night sky. Now, the optics of his day were incredibly primitive.
It's glass in a tube, basically.
Exactly, just ground glass in a wooden tube. So he didn't see the majestic, crisp rings we photograph today.
So what did he actually see through that early lens?
Well, he saw a blurry central planet flanked by two smaller stationary lumps on either side. He was so confused by the shape that he actually wrote in his notes that Saturn appeared to have ears.
Ears. A planet with ears. That had to be completely baffling for him.
It gets better, actually. A couple of years later, Galileo looked at Saturn again, and the ears were gone.
Wait, gone? Like completely vanished?
Completely vanished. He was looking at a totally smooth, bare sphere. He genuinely thought he was losing his mind. Or, perhaps that his telescope was just broken.
Oh, wow.
Yeah, and he never lived to understand what was actually happening. It took another half-century, and the significantly improved telescopes of a Dutch astronomer named Christian Huygens to solve the mystery of the vanishing ears.
Okay, so if the ears weren't actually disappearing, what was Huygens seeing that Galileo missed?
Huygens realized that Saturn is surrounded by a wide, flat disk that doesn't physically touch the planet at all.
Okay.
And the reason Galileo's ears seem to vanish is purely about the viewing angle. As Earth and Saturn move along their respective orbits around the Sun, our perspective shifts. So every 15 years or so, Earth views Saturn's flat disk exactly edge-on.
Oh, I get it. Picture this in your head. But if you hold that same dinner plate perfectly level, right at eye level, it almost disappears into this thin line.
That is the exact mechanism. But the reason Saturn's rings vanish entirely from our view when seen edge-on revealed an aspect ratio that is just almost impossible to fathom. I mean, these rings stretch about 280,000 kilometers across.
Which is almost the entire distance from the Earth to the Moon. Just a massive, mind-boggling expanse of space.
Huge. Yet despite being nearly a lunar distance wide, the main rings are, on average, only about 10 meters thick.
10 meters? Wait, really?
Yes.
That's the height of a 3-story building. So if I'm trying to visualize this scale, you shrank the entire ring system down so it was as wide as an American football field. The rings wouldn't even be the thickness of a piece of cardboard, right?
We're not even close.
They would be significantly thinner than a single sheet of tissue paper resting on the grass.
It's absurd. A structure that impossibly wide and that unfathomably thin defies our everyday intuition of how solid objects behave. For a long time, the prevailing visual illusion was that astronomers were looking at a solid sheet, perhaps a giant cosmic frisbee spinning around the planet.
But logically, if you have a structure the size of the Earth-Moon distance, but as thin as tissue paper, a solid object of that size would just snap under its own weight, wouldn't it?
Oh, it would instantly shatter. And in the 1850s, a Scottish physicist named James Clerk Maxwell proved this mathematically.
Without ever going to space, obviously.
Exactly, without ever leaving his desk. Maxwell calculated that Saturn's immense gravitational pull exerts a massive shear force on the space around it. So gravity pulls significantly harder on the inner edge of a ring than it does on the outer edge.
Right.
If the ring were a solid sheet of rock or ice, that differential pull would just tear it to pieces.
Okay, so if it isn't a solid sheet, what did Maxwell's math conclude was actually circling the planet?
He deduced it had to be a swarm, just uncountable, disconnected particles, each orbiting independently. And modern spacecraft have confirmed he was entirely correct.
Wow.
The rings are composed of trillions upon trillions of chunks of almost pure water ice. And they range in size from microscopic dust grains up to massive, jagged boulders the size of a house.
That completely changes the picture for me. So when we look through a telescope and see this bright, continuous halo, we are basically falling for an optical trick.
Exactly.
Is it kind of like looking at a snowfield from a few miles away? Like, from a distance, it looks like one smooth, pristine white blanket. But if you bend down and look closely, you realize it's just a blurry collection of billions of individual disconnected snowflakes catching the sunlight.
That is a wonderful analogy, actually, yes. And every single one of those icy snowflakes is acting as its own independent tiny moon orbiting Saturn.
Yeah.
But the realization that the rings are a swarm of trillions of independent boulders immediately introduces a severe physics problem.
Let me guess. Swarms are usually chaotic.
Right.
When I think of a swarm of bees or a flock of birds, they form these big, fat, spherical clouds. So why on earth is this icy swarm impossibly perfectly flat?
Well, it comes down to millions of years of cosmic bumper cars.
Bumper cars.
Yeah, when this ice first formed around Saturn, the boulders likely had all sorts of chaotic, highly tilted, crisscrossing orbits. But over time, objects on intersecting paths are inevitably going to bump into each other.
Wait, hold on. If you have trillions of house-sized ice boulders constantly slamming into each other at orbital speeds, wouldn't they just violently shatter and scatter into an even bigger, more chaotic cloud? Like, how does smashing boulders together create a flat sheet of tissue paper?
That is a very natural assumption to make, but the secret lies in their relative speed. Because all of these ice chunks are orbiting Saturn in the same general direction, they aren't colliding in catastrophic head-on highway crashes.
Oh, I see.
They are moving at roughly the same speed, so when they meet, it is much more like a gentle sideswipe between two cars traveling in the same lane.
Ah, okay, so the impacts aren't actually destroying them.
Far from it. Every time two ice chunks gently bump into each other, the collision absorbs and cancels out a little bit of their vertical up and down motion. The energy of that vertical wobble is lost in the bump, but their forward circular momentum just keeps going.
So collision after collision, century after century, all the chaotic up and down movement just gets slowly ironed out.
Yes, ultimately, the entire swarm settles into a single, razor-thin plane where nothing is bumping up or down anymore. And the beauty of this is that Saturn is demonstrating a fundamental law of physics in miniature.
Really?
Yeah, this exact same process, gentle collisions canceling out vertical motion over time, is the reason why our entire solar system is a flat disk, and why galaxies like the Milky Way are flat spirals rather than round balls.
That is incredible. Okay, so the gentle bumper cars explain how the swarm irons itself flat. But if these ice chunks are constantly nudging each other and spreading out into this flat sheet, why isn't the sheet just one big, continuous blur? Because when you look at high-resolution photos of Saturn, there are razor-sharp, distinct gaps in the ice, almost like the dark grooves on a vinyl record.
Yeah, the most prominent of those grooves is known as the Cassini division. It's a gap so massive, thousands of kilometers wide, that you can actually see it with a decent backyard telescope right here on Earth.
Oh, really?
Yeah. And the ice chunks didn't just, decide to leave that space empty. The rings are actively being sculpted, and the sculptors are Saturn's moons.
So the moons are somehow sweeping the floor to keep these gaps perfectly empty.
Okay.
How do they do that from so far away?
They do it through a fascinating gravitational mechanism known as orbital resonance. This happens when two orbiting bodies have orbit times that align perfectly in a mathematical ratio. It allows them to exert a regular, rhythmic gravitational pull on each other.
Okay, I usually hear the word resonance and think of, like, music or acoustics. What does that rhythmic pull actually look like for a chunk of ice out in space?
Let's focus on that massive gap, the Cassini division. Imagine a solitary chunk of ice sitting right in the middle of that empty space orbiting Saturn. Further out from the rings, Saturn has a moon named Mimas.
Okay.
Because of the distances involved, the time it takes that ice chunk to orbit Saturn is exactly half the time it takes the moon Mimas to complete one orbit.
So for every one lap the moon makes, the ice chunk makes exactly 2 laps.
The math lines up flawlessly. This means that every single time the ice chunk reaches the exact same physical spot on its second lap, the massive moon Mimas is returning to the exact same spot on its first lap. And when they align, Mimas's gravity gives that tiny ice chunk a subtle tug.
Oh, I love this. Think about pushing a child on a swing set. If you walk up to a moving swing and just push it at random chaotic times, you might actually slow it down, or it just won't go very high. But if you stand in one spot and you give that swing a perfectly timed push every single time it comes back to you, that energy compounds. The swing goes higher and higher.
That is the perfect way to visualize it. Mimas is standing there, giving the ice chunks a perfectly timed gravitational push on every second orbit. Over time, that rhythmic energy builds up so much that the ice chunks are literally flung out of their lane. They are pushed into a different orbit entirely, leaving behind a sharply defined, completely empty gap.
It's essentially a cosmic sculpture carved by gravity. But as breathtaking as this intricate structure is, the essay we are looking at points out that there is a massive scientific scandal hiding in all this icy beauty.
Yes, a very stubborn problem for planetary scientists. For decades, the default common sense assumption was that Saturn's rings must be ancient. Astronomers just assumed they formed 4.5 billion years ago, right alongside Saturn and the rest of the solar system.
Which seems entirely logical. You have an ancient planet, it probably has ancient rings.
Right. The issue is that outer space is incredibly dirty.
Dirty?
Yeah, our solar system is teeming with micrometeoroids. These are essentially tiny flecks of rock, carbon, shattered asteroid debris, and space dust that are constantly zipping through the void. They strike everything in their path.
So if the rings have been sitting out in space for 4.5 billion years, they should have been bombarded by this cosmic grime.
Relentlessly. A continuous rain of dirty space dust over billions of years should have heavily polluted the rings. They should look like dark, charcoal gray, soot-covered bands.
Oh, wow.
But when we look at the data, Saturn's rings are shockingly bright. They reflect an enormous amount of light because the ice is over 95% pure, pristine water ice.
It's exactly like a fresh snowfall next to a busy highway. If that snow has been sitting there all week, the exhaust, the tires, and the dirt kick up and turn it into this dreary gray slush. The only way you get bright, brilliant white snow next to a highway is if it literally just fell this morning.
That's right. The cleanliness of the rings is undeniable. Because they are so bright and pure, the mathematical models suggest they simply cannot have been sitting out in the dirty environment of space for billions of years. The shocking conclusion is that the rings might only be about 100 million years old.
That timeline is what really stops you in your tracks. When you say 100 million years old, that means during the Cretaceous period on Earth, when dinosaurs like the Triceratops were walking around, Saturn was just a bare, ringless globe.
Yeah.
The most famous feature in the solar system is younger than the dinosaurs.
It forces a complete paradigm shift. The rings are not an eternal, permanent fixture of the planet. They are a very, very recent addition.
Which immediately opens up a rather violent mystery. If this massive, pristine halo of ice was born so recently, where on Earth did trillions of tons of fresh ice suddenly come from?
Well, to get that much fresh material that recently, you need a cataclysmic event. The leading scientific consensus is that in the geologically recent past, a large, icy moon, perhaps roughly the size of our own moon, wandered just a little too close to Saturn's upper atmosphere.
Why is getting close so dangerous?
Because of tidal forces.
Tidal forces?
Yeah, when an object gets extremely close to a gas giant like Saturn, the gravitational dynamics become highly localized. So Saturn's gravity pulls significantly harder on the near side of the approaching moon than it pulls on the far side of that same moon.
Okay, I usually hear the word tidal and think of like the moon pulling on Earth's oceans to create high tide. Are we talking about the same kind of physical stretching?
The exact same principle, but scaled up to a lethal degree. The differential pull from Saturn is so extreme that it literally begins to stretch the icy moon out of a spherical shape. As the moon crosses a specific boundary called the Roche limit, the stretching overcomes the moon's own internal gravity.
Oh, man.
The structural integrity fails entirely, and the moon is ripped limb from limb.
So an entire moon was just shredded into trillions of icy fragments.
Exactly. And those shattered fragments spread out over millions of years, colliding and flattening into the pristine disk we admire today. The rings are quite literally the beautiful, shimmering remains of a murdered moon.
It's an apocalyptic origin story for something that looks so tranquil. But the drama doesn't stop at their birth, does it? The essay highlights that if they were born recently, they are also destined for a very rapid death.
Yes, they are actively dying as we speak.
Wow.
This was a difficult realization for the astronomy community, and the first major clues actually came from the Voyager spacecraft missions back in the 1980s. The data revealed that the icy swarm is slowly but steadily drizzling down into Saturn's atmosphere.
Wait, how does ice orbiting in space just start raining down onto the planet?
It is a process scientists call ring rain. Out there in space, the tiny ice particles are constantly bathed in ultraviolet sunlight. This harsh radiation actually knocks electrons around, giving the ice particles a tiny electrical charge.
And once they have an electrical charge, they start interacting with magnetic fields.
Precisely. Saturn possesses an immense, powerful magnetic field. Once those ice chunks are electrically charged, they get caught in the planet's invisible magnetic field lines. The magnetic field acts like a giant funnel, dragging the charged ice particles out of their stable orbits and pulling them down into Saturn's upper atmosphere, where they vaporize.
It's like a relentless, invisible downpour.
Yeah, and based on the current rate of this ring rain, astronomers calculate that the entire ring system could be completely gone in just a few 100 million years.
I mean, a few 100 million years feels like forever to a human, but on a cosmic scale, where the solar system is 4.5 billion years old, that is an absolute blink of an eye.
They are entirely ephemeral. They didn't exist for most of Saturn's history, and they won't exist for most of its future.
Now, we've covered some incredibly radical theories here. The rings are tissue paper thin, they're made of a shattered moon, they're shockingly young, and they're evaporating. But we couldn't just stare through telescopes from Earth to prove the age and the mass. We had to actually go out there and weigh them.
Right, and this brings us to one of the most daring feats in the history of space exploration, the Cassini spacecraft. Cassini spent 13 years orbiting within the Saturnian system, weaving past moons, discovering underground oceans, and completely revolutionizing our understanding of the planet.
But by 2017, the mission faced a crisis, didn't it? Cassini was running perilously low on maneuvering fuel.
It was. And the team at NASA faced a serious planetary protection dilemma.
How so?
Well, Cassini had discovered that moons like Enceladus harbor liquid water oceans beneath their icy crusts, making them prime real estate in the search for alien life. If Cassini simply ran out of fuel, it would become a dead, uncontrollable ghost ship. Years or decades down the line, its orbit could decay, and it might crash into one of those pristine moons, potentially contaminating a habitable environment with surviving Earth microbes.
So to protect those potentially life-bearing moons, Cassini had to be destroyed.
NASA decided to execute what they called the Grand Finale. They deliberately piloted the spacecraft on a series of breathtaking, needle-threading suicide dives right through the narrow, unmapped gap between Saturn's upper atmosphere and the innermost edge of the rings.
Traveling at thousands of miles an hour through a gap no machine had ever flown through. The tension in mission control must have been suffocating. I read they even had to use the spacecraft's large radio antenna as a physical shield against any stray ice particles.
Yeah, it was a spectacular way to end the mission. And on those final fatal orbits, right before Cassini plunged into the crushing atmosphere of Saturn to burn up like a meteor, it accomplished something unprecedented. By flying between the planet and the rings, the spacecraft's radio signal allowed scientists on Earth to track its speed down to a fraction of a millimeter per second.
And by tracking that speed so precisely, they could feel the tiny gravitational tug of the rings pulling on the spacecraft. They essentially used Cassini as a giant cosmic scale.
They weighed the rings, and the ultimate smoking gun was that the mass Cassini measured was astonishingly low. The rings are lightweights.
Why does a low mass prove they are young?
Because a lighter, less massive ring system is much easier to push around, much easier for micrometeoroids to pollute, and much faster to drain away as ring rain. If they were heavy and massive, they might have had the bulk to survive for billions of years. But that extremely low mass measurement tipped the scientific consensus firmly toward a youthful recent origin. In its final moments, Cassini solved a mystery that started with Galileo's confusion over a planet with ears.
It is a stunning legacy for a machine. So let's step back and look at the entire picture we've painted today. You look at an elementary school textbook, and you see this serene, solid, eternal halo surrounding a giant planet. But now you know the truth.
The tranquility is a complete illusion.
It is a temporary, violently disintegrating cloud of trillions of jagged ice boulders. It is the shattered corpse of a doomed moon, held in a sheet thinner than tissue paper by a constant rhythm of gentle collisions, intricately carved by the gravitational push of other moons. And it is quietly raining to its death into the planet, even as we sit here talking about it.
The sheer chaotic dynamism of it all is endlessly fascinating.
More than anything, it highlights our profound, incredible luck. Out of the billions of years of solar system history, humanity managed to evolve, invent the telescope, and look up during the exact incredible brief cosmic window to see Saturn wearing its absolute finest ornament.
You know, if we look at the bigger picture, it actually raises a really provocative thought about how we view the rest of the universe.
Oh, yeah.
Yeah, if Saturn's rings are just a fleeting phase, the messy aftermath of a destroyed moon, it strongly suggests that planetary rings are not a unique Saturn thing.
Meaning they aren't a permanent feature, but a life cycle stage.
Precisely. The majestic rings we see today are just a snapshot in time. It invites you to look up at the night sky and reconsider our other neighbors. Look at Jupiter, Uranus, Neptune. Which of those other giant planets might have once worn a brilliant, spectacular halo of their own hundreds of millions of years ago, while the Earth was still devoid of telescopes?
Wow, that is wild to think about.
And perhaps even more thrilling to imagine, which of the planets out there are destined to drag one of their own moons too close, tear it apart, and wear a majestic new set of rings in the distant future long after we are gone.
That is a phenomenal thought to leave on. The universe isn't a static painting, it's a moving picture, and we just happen to walk into the theater at the best possible moment. So the next time you see that cliche drawing on a lunchbox, or you see that perfect hula hoop around the planet, don't just gloss over it. Remember that what you are looking at isn't just a shape. It's a snapshot of a fleeting, beautiful catastrophe. Thanks for joining us on this deep dive, and keep looking up.